Hi folks, we're now looking at number 2 from Unit 6, Quiz 2, and what we have is a function given, and this function represents for the y values the profit made by selling computers, and the x value, which is represented by n here, represents the number of computers that are being sold. Okay, and what we want to do in part A is determine the maximum profit she can expect to make in a month and how many computers she has to sell. So when you think about what they're asking for the x and y values or the n and p values at the maximum. Okay, so essentially we're looking for the vertex. Okay, since we have a negative a value, we know that looking for a maximum makes sense. Okay, so since we're looking for maximum here and we have standard form, I would say the most appropriate course of action is to complete the square. Okay, so let me take this function. I remember what this p of n is, just function notation, so the y value for this given x value. Okay, and we're going to rewrite this in vertex form. Okay, so we'll start by factoring out the negative 3 from the first two terms. So negative 3, so here we're left with n squared, and 300 divided by negative 3. Okay, that leaves me with minus 100n. Okay, and we're not going to worry about the minus 4,500 until the end. Okay, so now let's go to completing the square. So we're going to write this as n squared minus 2 times, oops, sorry, this should be n here, not x, since that's our variable. So I'm going to write this as 2 times 50n. Okay, so this is going to be my h value. And now I'm going to have to add 50 squared and subtract 50 squared in order to be able to complete the square, but also not change the value of my expression. Okay, so inside the bracket, the first 3 terms are going to give me my perfect square of n minus 50 squared, and then I'm left with this minus 50 squared, which is minus 2,500. Okay, and now it's just a matter of cleaning things up, so I'm going to distribute this to both terms, so now I'm left with negative 3 n minus 50 squared, and this is going to be 3 times 2,500, so plus 7,500 minus 4,500, and now we'll do that last subtraction. Okay, so 75 minus 45, so that's just going to be 3,000. Okay, so this form here, this represents my h value, my k value, my x value, the vertex, my y value, the vertex. So what we're looking for is the maximum profit. So that's the maximum y value. So our maximum profit is given by the k value here. So that's $3,000. And the x value of the vertex tells me how many computers I have to sell in order to give me my maximum profit. Okay, number of computers, 50. Okay, so this solves this problem. Now let's take a look at part B. It says determine how many computers she would have to sell to break even. So first of all, just a reminder as to what this term break even means. This means you're neither making money nor losing money. So in other words, your profit is going to be equal to 0. Okay, so I need to set my profit to 0. Now, I could work with this form here with standard form, and if I wanted to determine the zeros or the x-intercepts, I could try factoring. Okay, these numbers are a little large, although I do notice that they're all divisible by 3. Okay, my other option is to use this form of the equation, since I've already put it in vertex form, and I can solve using opposite operations. Okay, so I'll actually probably do that in both ways and see how this works. Okay, we'll see if it works out nicely. So I set p to 0, and I'll start with vertex form instead of factored form. Okay, so I got negative 3 n minus 50 squared plus 3,000. Okay, so now in this form, I'm actually able to solve using opposite operations. So let's bring the 3,000 to the other side. So I got negative 3,000. Okay, once I bring that to the other side, I can divide by negative 3. Okay, so this I'm left with 1,000. Okay. Now, in order to solve the next step, I have to do the opposite operation of squaring, which is taking the square root. And this is where I have to be careful because I need to consider both the positive and negative possibility. Okay? Because I might have two possible answers here. Now, if this was just a straight math question, I would leave this as plus or minus root 1,000. But since this is an application question, and beyond that, I also need an answer that's going to be an integer, it makes sense to estimate this root 1,000. Okay, so let's do that here. So square root of 1,000. Okay, so we got about 31.6. So this is about 31.6. Remember, both positive and negative possibility. And now I can solve for n. So I have to consider both possibilities. Either n is equal to 31.6 plus 5. Oh, sorry, plus 50. Okay, clear that up. So that's going to be 81.6. Or n could be equal to negative 31.6 plus 50. Okay, and that there looks like it's going to be 18.4. Now, since both of these numbers are positive, it means they're both reasonable to solve this problem. Had one of these been negative, it wouldn't have made sense to talk about negative computers. However, when I give my answer, I have to give my answer in integer form, since I can't sell part of a computer. Okay? So here, I'm not going to be too picky on how we do this. You can try to think which one will give you an answer closer to 0. So I'm just going to say, let's round as we would normally round. Okay? So I'd say here, she could sell either 82 computers or 18 computers. Okay? And in either of these scenarios, she'll neither make money nor lose money. Now, since in the end this didn't come out to a nice number, I'm going to guess that factoring this probably wasn't going to be easy, so I'm not even going to bother with it. Okay, so remember, keep in mind the inconvenient part of factoring is it doesn't always work. Okay, so here again, notice just to recap. Okay, I chose to work in Vertex Form in part 1 because I was specifically looking for the maximum, and I had standard form given to me. In part B, since I already had it in Vertex Form, it made sense to solve using opposite operations from that form there. Okay, so you want to choose which form to work with based on what you're looking for and what you have. Okay, that's it for this one.